Hello, and welcome to the first lesson in the unit on Earth's place in the universe. This first lesson is intended on being a review of what you learned in 6th and 7th grade to make sure that you have what you need to start the new lesson. We have 3 essential questions that you'll want to be able to answer by the end of this lesson. You should write these questions down in your notebook so that you're able to answer them by the time you finish this lesson. Your questions are, how are the inner planets different from the outer planets? A nice way to do this in your notes is to make a Venn diagram. Our second essential question is, what is an astronomical unit and why is it used? And the last one is in regards to the shape of planets' orbits. We have 5 vocabulary words that go along with this lesson. We will be doing the vocabulary as in class as part of our interactive notebooks, but please make note of these vocab words now. This picture is an artist's representation of our solar system. It is not drawn to scale. You will see that on the left-hand side of the picture is our sun. Then our planets going out in order are Mercury, Venus, Earth, which is depicted with a picture of our moon, Mars, Jupiter, Saturn, Uranus, and Neptune. There's also a picture of the asteroid belt, which lies in between Mars and Jupiter, and there's a comet flying by Jupiter as well. Our sun is mostly made of hydrogen gas. It has a diameter of approximately 1.4 million kilometers. That makes it 10 times larger than Jupiter, which is the largest planet in our solar system. The sun contains 99% of all of the mass in our solar system. So everything else, all of the other planets, the asteroids, the dwarf planets, the moons, the comets, everything else is only 1% of the mass of our solar system. The sun provides all of our energy ultimately. And the sun creates energy through a process called nuclear fusion. And nuclear fusion is when 2 elements combine or fuse together to create a new element. And when that happens, large quantities of energy are released. Our sun is fusing hydrogen into helium. Because our sun is the largest thing in our solar system, it has the most gravity of everything else in our solar system, which is why all of the other planets orbit around the sun. There are 3 types of planets. We have our inner planets, which is Mercury, Venus, Earth, and Mars. The inner planets are made of solid, rocky materials. They have solid outer crusts. They're also called terrestrial planets. Next is our outer planets. Our outer planets are called the gas giants, and this is because they are made predominantly of ice and gas, although it is believed that they have solid cores. All of the outer planets have moons and rings, even though on some of the planets the rings are very hard to see. And the last classification is dwarf planets. You may remember when you were little that Pluto was one of the planets. We had 9 instead of 8. And then Pluto was reclassified as a dwarf planet. But we actually have more dwarf planets than just Pluto. We have Eris, Pluto, Haumea, Makemake, and Ceres. And Ceres is actually located within the asteroid belt. Astronomical units are a unit of measure. Just like meters and miles and kilometers, it's a unit of measure. And the astronomical unit is defined as the average distance between the Earth and the Sun. Astronomical units are used to measure distances within our solar system. And we use them because using kilometers would be just far too large. You can see at this table here, the Earth is almost 150 million kilometers from the Sun, where it's one astronomical unit. And if you look at Neptune, Neptune is 30 astronomical units from the Sun, and you can see what a very large number of kilometers that is. Now, our dwarf planets are not on this chart, and some of them are closer to the Sun. Like Ceres is only 2.3 astronomical units from the Sun. It is in between Mars and Jupiter in the asteroid belt. Pluto is just a little bit past Neptune, and its distance is between 30 and 49 astronomical units, depending on where it is in its orbit. Makemake and Haumea are both 50 astronomical units, and Aries is the farthest one out at 96 astronomical units away from the Sun. So it's more than 3 times farther away from the Sun than Neptune is. Planets revolve the Sun in elliptical orbits. Now, an ellipse is like an oval. So they're not completely round. An oval is like a circle that's been squished just a little bit. Now, we talked about how much gravity the Sun has, and that gravity is what causes the planets to orbit around the Sun. The force is called centripetal force. And we'll learn a lot more about centripetal force when we start talking about Newton's laws of motion later on this school year. But for now, you just want to remember that the name of the force that keeps all those planets in orbit is centripetal force. Now, there are 2 time periods that we need to remember when we're talking about how planets move. And the first one is the period of revolution. Now, the period of revolution is the amount of time it takes a planet to complete one full orbit around the Sun. On Earth, that's 1 year, a little over 365 days. Now, in addition to revolving around the Sun, planets are rotating on their axis. And the amount of time that it takes a period to rotate on its axis is called the period of rotation. So that's the equivalent of a day on a planet. On Earth, it's about 24 hours. This is a picture of how a planetary orbit would look. This isn't any planet in particular, but planets move around the Sun in an ellipse. And there are 2 reference points that astronomers use to describe the orbit of a planet. And those are called focal points. And in this diagram, they're labeled F1 and F2. Now, F1 is always the Sun. F2 is a place in empty space, but the distance from F1 to the edge of the orbit, so where the planet is closest to the Sun, that distance is the same from the focal point 2, F2, to the outer edge of the orbit. That's how we figure out what those 2 are. When planets are orbiting the Sun, the speed of that orbit is not the same all the time. As planets get closer to the Sun, because the sun's gravity gets stronger when you get closer to it, the orbits actually speed up. So as we are revolving around the sun every year, during the times when we're closer to the sun, we're actually going faster than during the times when we're farther away from the sun. If you would like to dive deeper into this topic, you should read Chapter 11 in the OWL textbook, Chapter 21 in the Leopard textbook, Chapter 2 in the Frog textbook, or you may watch the quick rundown of the solar system video on Edpuzzle. The video on Edpuzzle is punctuated with questions to help you take notes and follow along with the video.